Hello all. I've chosen the paper Secure Authentication Scheme for Internet of Things in Cloud. This paper was published in 2018, Third International Conference on Internet of Things, Smart Innovation and Usages. The Internet of Things is composed of physical objects embedded with electronics, software, and sensors, which allows objects to be sensed and controlled remotely across the existing network infrastructure, facilitates direct integration between the physical world and the computer communication networks, and significantly contributes to enhanced efficiency, accuracy, and economic benefits. Therefore, IoT has been widely applied in various applications such as network monitoring, healthcare systems, energy management, etc. So however, in the IoT, there are resource constraints. So it always outsources all the data to the cloud, which is collected by the IoT devices. This outsourcing of data to the public cloud raises security issues such as authentication, confidentiality, and integrity. So because the data transmission from IoT devices to cloud faces various attacks such as eavesdropping, modification, and leakage, a malicious cloud user intends to forge its identity, manipulate the transmitted data. So the false data that is manipulated could lead to authorized users' inconvenience, so which should be prevented. Therefore, it is required to propose a system or a secure authentication scheme to avoid false identity, data modification, or leakage during transmission, and reduce both the computational and the communication cost. Although several schemes have proposed to address the security issues in the IoT, the scalable authentication, confidentiality, and integrity of the data is not well addressed. So this paper, they are proposing a secure authentication scheme for IoT in the cloud to ensure the authentication along with the confidentiality and integrity based on elliptical curve cryptography and Chebyshev polynomials. So, considering the three threats: authentication, data leakage, and modification of the data, the devices in the IoT should be authenticated because of the large number of devices. Data leakage in IoT, there is a serious risk of data leakage during the transition. It is a serious threat in IoT security. Modification of data in IoT, data can be modified or deleted during the transmission. So it is mandatory to verify that the integrity of the data during this transmission is maintained. So when it comes to the system architecture in the IoT, the IoT architecture consists of a sensor layer which will sense the data, and the network layer that will transfer the data between the IoT devices and the cloud, and a cloud layer which is used to store the data. The previous schemes which were proposed by Ning et al. And Hu et al. So they had disadvantages where there were more computational overhead. So Ni et al. Proposed aggregated proof based hierarchical authentication scheme for a unit IoT. So in this scheme, the aggregated proof are established for multiple targets to achieve backward and the forward security during data transfer, and directed path descriptors. So the homomorphic functions and the Chebyshev chaotic maps are applied for mutual authentication. And in Hu et al. Model, he proposed a security and privacy of face identification and resolution using fog computing to ensure authentication along with confidentiality and the integrity. So anyways, in these two models, there were more computational overhead while ensuring the security. So this paper proposes a secure authentication scheme which is achieved by using Chebyshev chaotic maps based on a pseudo random number algorithm. So it uses elliptical curve cryptography to achieve confidentiality and integrity of data during the data transmission, and the security and the performance of this proposed scheme is like analyzed using the performance analysis and how it is better than all the existing schemes. The proposed authentication scheme has two parts, the authentication phase and the transmission phase. So in the authentication phase, considering the scanner and the tag pseudonym, the random numbers, the hash function, and the concatenation operator. So the authentication phase is split into three main parts: the authentication between the scanner and the tag. So the authentication on both the scanner and tag by the cloud, and the authentication on scanner by the tag. So in the authentication between a scanner and the tag, to ensure the authentication between this, the scanner, yes, so the name yes generates the pseudo random number and it transmits across to the new section. So in the authentication between the scanner and the tag by cloud C, again there is like the pseudonyms are calculated and there is some mathematics equation that is involved here using the hash values. So in the transmission phase, again encryption and integrity verification is managed. The security of the proposed scheme is analyzed in terms of authentication, confidentiality, and integrity. So in this scheme, the authentication between the tag, scanner, and the cloud is considered. So during the authentication, each device need to verify other identity and verify the hash values computed by each device. In the process of authentication, they are using Chebyshev chaotic maps, which indirectly imply the process of identity authentication. Furthermore, the authentication mechanism can resist replay attack by sending and verifying random numbers generated by the two communication devices. So the scheme can ensure that like we can prevent illegal devices from obtaining access authority. The next, data confidentiality. So in this scheme, data is encrypted to ensure the confidentiality in the processes of data transmission and storage. So in the process of encryption, elliptical curve public key encryption mechanism is used to encrypt the data and store it in the cloud. So this encryption algorithm can effectively protect the data from being accessed by unauthorized users because the keys are generated randomly and are encrypted. So the attacker cannot guess the key. So hence confidentiality is again achieved by using this method. And the third one is the data integrity. So in order to ensure the data integrity from being altered during the transmission between the scanner and the cloud, data integrity verification algorithm based on HMAC is implemented. HMAC function can convert arbitrary length of data into fixed length to digest. So any changes occurred in the transmission of data, it causes the change in the result of fixed length of digest also. The cloud is able to recover the changes about the data by comparing the hash values. Furthermore, in the data storage process, we also adopt hash data integrity checking hash algorithm based on HMAC to verify the integrity of the data access process. It effectively detects the data alteration in the cloud done by the attacker. So in the performance analysis section, the proposed scheme is analyzed for the efficiency of computational cost, communication cost, and the storage requirement. So authentication scheme using skith tool for creating virtual devices and the OpenStack is used. So for analyzing the proposed scheme, a local cloud platform using OpenStack Swift is deployed. So to conduct the experiments, a test environment using Linux machine, which is having an Intel i5 quad core CPU with 8 GB of RAM with a clock speed of 3 GHz and 64-bit Ubuntu operating system is used. So again, MATLAB is installed in the Intel i5 processor. So MATLAB is used for experimental result computation. So here the computation cost, the communication cost, and the storage cost is proved to be efficient than other existing schemes which were already in use. So this paper mainly focused on the security issues of IoT and proposed a secure authentication scheme for IoT in the cloud. The authentication between the devices and the cloud is achieved by using Chebyshev polynomials and random numbers. The confidentiality and integrity of the data during transmission is achieved by elliptical curve cryptography, based encryption, and hash values. Through security and performance analysis, the security and efficiency of this scheme is proved. Hence, this scheme is suitable for lightweight IoT based applications in the cloud.